number 13. Here we go. Lesson number 13. I want you to read the first sentence on this lesson. It reads, angle 1 plus angle 2 plus angle 3 is equal to angle 4 plus angle 5 to angle 6 is equal to angle 7 plus angle 8 plus angle 9 equals 180. What does that sentence mean? Yes, ma'am.
That all the triangles have the same sum of angles.
Okay, which is?
180 degrees.
180 degrees. Which comes up with our new vocabulary word of the day, which is angle sum theorem.
That's actually
The angle sum theorem is, I erased it and I apologize about that.
Is this the definition?
Yep, the sum of the interior angles of a triangle is always 180 degrees. Okay? The angle sum theorem states the sum of the interior angles of a triangle is always 180 degrees, which means no matter what triangle you build, if you add up the interior angles, you will always get 180. Now, if you look at the picture on this front page, sorry. Finish ready. Copy from a neighbor if you're not done at this point is always 180 degrees. Why did they choose these three triangles to picture?
Because they don't look the same at all.
Not only do they not look the same at all, we have three types of triangles. Go ahead.
You can line them up to make 180 degrees.
No, you can't. Not with these three triangles. Yes?
You have an acute, obtuse, and a right angle.
Very good. You have an acute triangle. All three angles are less than 90 degrees. You have one obtuse triangle that is displayed. It has one angle greater than 90 degrees. And you have a right triangle which has one angle that is exactly 90 degrees. And out of the three types, it doesn't matter which one you build, the interior angles, should we measure them, will always be 180 degrees. What we are going to do today is we want to prove that the angle sum of any triangle is 180 degrees. To do so, we will use the facts that we already know. We know that a straight angle is 180 degrees. We know that corresponding angles of parallel lines are equal. And we know that alternate interior angles of parallel lines are equal. Since you know that all those facts, we are going to be able to prove that all triangles create 180 degrees. Let's go to exercise challenge number 1. Challenge number 1. Challenge number 1 reads, let triangle ABC be given. Does everybody see the given triangle ABC?
Yep. Yes.
All right. Now they've done this drawing for us. It says on the ray from B to C, take a point D so that C is between B and D. The book created this for you. It created the ray, BC. It created point D beyond C, so C is between B and D. Through point C, draw a line parallel to AB as shown. Label the line with an E. So ladies and gentlemen, the information it just gave us that you need to include in your picture is it just told us that AB and CE are parallel. The notation for parallel lines in a drawing is a little triangle on each line. So there is our notation for a pair of parallel lines. this will remind me as I work through this problem that these two lines are parallel to one another. Now, with your handy-dandy rulers, you are going to extend parallel lines A, B, and C, E. Take out your handy-dandy rulers to assist us in discovering that all triangles create 180 degrees. We are going to extend AB and CE. With your rulers, extend those two parallel lines. The next one says that line AC is the transversal intersecting the two parallel lines. So to make sure that I can see that it's a transversal, I am also going to extend my line AC. Is AC my only transversal through these two parallel lines? Nope, Mr. Osborne, where else do I have a pair of where else do I have a transversal cutting those parallel lines? BCD is another transversal. So to make sure, if you would like to label those transversals, you can write the word transversal next to it so you remember. But you have these two parallel lines. Press pause. Now we're going to answer question 1. Name the 3 interior angles of triangle ABC. So we have a triangle ABC. How do we name angles? Okay, can I say angle A?
Yeah.
Okay, what would be wrong with labeling it angle A? How many angles exist at letter A? I can identify 1, 2, 3, 4 angles at A. I also identify a straight angle here and a straight angle here. How do you eliminate what angle you're talking about?
Here the other 2 points.
Angles are listed by their starting point. I'm going to start at B, and then I'm going to travel to A, and I'm going to end at C. How many different points start at B, travel to A, and end at C? There is one and only one angle. Angles are listed with this symbol means angle, a starting point, a middle point, and an end point. I know angle BAC has to be that angle with no other options. Give me another angle in the triangle. BCA is my next angle inside the triangle. B to C to A is this triangle right there.
Isn't there another one?
And the last angle inside my triangle, because all triangles are made up of 3 angles, is
C. So it's
angle
just
C to B
to
to
A.
A. That is that angle right there. Are there any questions about the 3 angles and how they have to be listed? Okay, let's take a look at question number 2. Name the straight angle. Now, in order to come up with an angle, you need how many points?
1.
How many points do you need for an angle that we just talked about?
3.
You need 3 points. How many different straight angles exist in this picture?
4. Oh wait, no, 3.
Where can you find 3 different straight angles?
BAC.
Angle BAC. BAC is not a straight angle.
Wait,
Oh, BACE.
You need
Where do you-
3 points to make one angle. A beginning point, a middle point, and an end point.
BCD.
Angle BCD travels from here to here to here. Are there any other 3 points that can create a straight angle in this picture? D, C, B, is that a different angle?
No.
Nope, it's still the same angle. We're just looking at it in the other direction. Are there any other straight angles?
No.
Nope, it's the only one. This is why it's important that you understand an angle is made up of 3 points. Now, if you notice in my picture, I've created different colors on my 3 angles to make things a little easier. What kind of angles are A, B, C? So that is my blue angle, and E to C to D. What type of angles are A, B, C, and E, C, D?
Acute.
Okay, now we're looking for an angle relationship. What we have alternate interior angles. We have alternate exterior angles, and we have corresponding angles. These two are corresponding angles. I have a pair of parallel lines. Both these angles happen to the bottom of the parallel lines cut by this transversal. So these are corresponding angles. Because they're corresponding, what does that mean about their measurements? The measurements are the same. Is it possible that they're different? Nope. No possible way for them to be different, because if these two lines are parallel, this is CE is simply a translation of BA, and you get corresponding or congruent angle measurements. What kind of angles are BAC, B to A to C, that's my red angle, and ECA, E to C to A, so this red angle right here. This angle and this angle. What would they be an example of in my 3 choices? Do they happen, corresponding angles happen on the same side of the transversal? Are these 2 angles on the same side of the transversal?
It would be interior.
Alternate interior. Here's your parallel line, so they're inside the parallel lines on opposite sides of the transversal. So these 2 angles are alternate interior angles. Therefore, their measurements are what? Measurements are the same. Because I can create one angle simply by rotating the lines, right?
Yep.
All right. Now, notice what angles, my angles inside my triangle are made up of blue, red, and green. Yes?
Yep.
Yes.
My straight angle that I know has a value of how much? 180 degrees is made up of a green, red, and blue angle. Well, if the straight angle is made up of the same degree measurements as inside my triangle, what do I know about my triangle measurement?
180 degrees.
It has to be 180 degrees. I've just proven to you that this triangle is 180 degrees. Your assignment is going to be to do on your own with the partner, so not on your own but with the partner, exercise challenge number 2. It presents the same type of problem, your ability to find the angle measurements. Are there any questions?
No.
Stop.